All right, so for my single board microcontroller challenge, I chose the Raspberry Pi. The Raspberry Pi came as a kit known as the Cana kit. So that's where I was able to get other pieces that would be useful in creating a useful product. So what came in my kit was the Raspberry Pi. I ended up using the GPI breakout board, which is this little black piece down here. And I used a ribbon cable in order to connect the Raspberry Pi to the GPI breakout board. And then I had the breadboard, which is where we put the jumper wires into. And then hidden in here, this black box, is a analog to digital converter that I used, and then we were connected to a water sensor. Some of the important aspects for this product is that in order to use it, you do need to have access to a computer monitor or like a TV. You do need a keyboard and you need a mouse to be able to run it. It's not something you can run on your laptop. Another thing is that this isn't exactly the most user-friendly of products. You have to be familiar with how to wire it correctly, and then you're also going to have to be familiar with the coding language. And so you are going to have to make sure to have time to teach all this stuff. Price-wise, I think it's very accessible though at $90 because you know, different groups can kind of share it to an extent. So for the purpose, what I decided to do was to focus on the Nebraska college and career-ready standards for science. It's a high school standard that basically says that asks the students to be able to design a solution to a complex real-world problem by breaking it down into smaller, more manageable problems that could be solved through engineering. And so that was my idea for what they could do with the Raspberry Pi. So specifically what I chose to do was, with last year's flooding that occurred, we did end up having water in our basement. And so I thought, well, it'd be interesting to create some sort of water sensor that could let you know when it gets some water on it, and then it can, the alarm part of it would be then that it sends an email. So I basically created this little water sensor that's hooked up through the breadboard and then GPI breakout board to the ribbon cable to my Raspberry Pi, and then the Raspberry Pi is hooked up to a computer monitor that we had, and then it's running this Python programming. All right, so for the preparation portion of it, I think what's really important to know is that, as I said, it's not the most user-friendly. There's a lot of different components, and if you want it to work properly, all those components do have to be connected, you know, in just the right way to ensure that you get a positive outcome. So really there's a lot of room for error, which could cause problems with students if they're not paying that close attention to detail. You know, as I said, you are going to have to be able to have access to some sort of computer monitor or a TV, keyboard, mouse in order to be able to program using the Raspberry Pi. And then in order for it to even do anything, you need to be able to write code. And so what I chose was Python coding, and it's not the most user-friendly. Also, I basically spent a lot of time using Google and trying to find where other people had already written the code that I could just copy and use. And then, although the kit comes with, you know, quite a few features, it doesn't come with any like sensors, and so that's where you may need to purchase additional pieces in order to be able to actually create a functioning product, just depending on what you want to do with it. And then to turn it into a lesson, my thought was to create a 2-day lesson as a summative assessment. And for this, the important aspects, the students are going to have to be able to work independently. They're going to have to be highly motivated. I feel like this is one where if they get frustrated, they may shut down rather than being like energized and challenged, because it might just get to the point that it's frustrating. And so you have to be careful of that. And as I said, it's not like with the computer programming, most people aren't familiar with their coding language, so you are going to probably have to build in some time just to teach learning and coding first. One thing that I did first was, and I thought could be used as a challenge for the students before releasing them to perform the product on their own, was just to have them demonstrate that they can basically illuminate a LED light bulb, because that in itself is not an easy task. And then for evaluation purposes, I was thinking, since the standard I chose is based on kind of the engineering design process, I think that when you are grading this as an assignment, you need to also take into account kind of those steps of the engineering design process. It shouldn't be whether or not their product functions at the end. I think you need to build in points just to demonstrate the process that they went through in order to get to that final product, because there's a lot of steps to get from here's the problem I want to solve, and then here is the product that I created for that. And so the next up is going to be the demo.